If you've ever wondered what enlisted members of the Space Force actually do all day, it's not laser swords, and it's not floating around pressing mysterious red buttons. It's satellites, signals, cyber warfare, and a surprising amount of staring at screens that determine whether civilization functions tomorrow morning. Today, we're breaking down every enlisted job currently listed by the Space Force, and by the end, you'll know exactly where each one fits in the orbital chessboard. Hello, my name is Gene Botkin. I study space and its growing importance in our daily lives. And I'm building a society for people who want to participate in the new space age. Today, we'll address jobs that enlisted members can acquire in the Space Force. Let's begin. 7 enlisted jobs exist. We begin with the backbone of the enlisted force, the Space Systems Operator. These guardians sit at consoles that control assets hundreds or thousands of miles above Earth. They track satellites in orbit, monitor onboard systems, and execute precise maneuvers that keep spacecraft where they need to be. If a satellite drifts, they correct it. If a sensor overheats, they respond. If telemetry spikes in an unexpected way, they investigate. Satellites are not decorative. They provide GPS timing signals that synchronize global finance. They enable secure military communications. They power missile warning systems that inform national leadership in seconds. Space systems operators are the custodians of that infrastructure. The work is technical and disciplined. Orbital mechanics is unforgiving. A small miscalculation compounds quickly. Precision is not optional. Operators also coordinate launches.
32 seconds into the flight.
Operations.
The 3 liquid fuel main engines soon will throttle back to 72% of rated performance down in the bucket, reducing the stress on the shuttle as it goes transonic.
It is procedural, methodical, and critical. In many ways, this role resembles air traffic control for objects traveling at thousands of miles per hour. The difference is that there are no visible contrails and no audible engines. Everything happens through data. Space is quiet. The consequences are not. Space systems operators ensure that the silent layer of modern civilization continues to function. Without them, the rest of the structure begins to wobble. Once the satellites are operating, someone must interpret the environment in which they move. That responsibility falls to the all-source analyst. These guardians gather intelligence from multiple streams and fuse it into coherent assessments. Signals intercepts, satellite imagery, open-source reporting, classified data. Each source alone tells a partial story. Together, they form a pattern. Pattern recognition is the core skill. An adversary launches a satellite. Another nation conducts a missile test. A new ground station appears in commercial imagery. None of these events are isolated. The all-source analyst connects them, evaluates intent, and briefs commanders who must decide how to respond. Space is increasingly congested and contested. Commercial constellations multiply. Rival powers expand their orbital capabilities. Debris fields grow. The operational picture changes constantly. The analyst's job is to impose clarity on that motion. Their work influences deterrence, posture, and readiness. A misjudged assessment can cause overreaction or complacency. Precision in analysis stabilizes strategy. This is not speculation. It is disciplined evaluation of evidence under time pressure. If space systems operators keep satellites alive, all source analysts explain the world those satellites inhabit. They translate raw information into decision advantage. But raw information itself must first be collected and interpreted at a technical level. That task belongs to a more specialized discipline, signals intelligence. Signals intelligence analysts work in a domain where nothing is visible, yet everything leaves a trace. Every radar sweep, satellite transmission, telemetry burst, and encrypted communication travels as electromagnetic energy. These signals can be detected, captured, and analyzed. That is the terrain of signals intelligence. These guardians operate systems that collect foreign electronic emissions and convert them into usable insight. They determine who is transmitting, from where, on what frequency, and with what pattern. Subtle changes in signal behavior can indicate testing, repositioning, interference, or preparation for something larger. Space is silent to the human ear. It is not silent electronically. In modern competition, adversaries probe one another constantly. They test jammers, they maneuver satellites, they experiment with counterspace capabilities. Signals intelligence analysts monitor these activities in near real time. Their findings inform both defensive and offensive planning. If an adversary begins emitting unusual telemetry, someone must detect it before it becomes operational reality. The work is technical and analytical. It requires understanding waveforms, modulation schemes, and transmission protocols. It also requires contextual judgment. Not every anomaly is hostile. Not every signal is significant. Discernment matters. Signals intelligence provides early warning. It reduces uncertainty. It reveals capability before it is demonstrated publicly. Yet many of the most consequential signals are encrypted or deliberately obscured. Interpreting those requires a deeper layer of expertise. Cryptologic analysis. Cryptologic analysts operate at the edge of comprehension. If signals intelligence identifies the existence of a transmission, cryptologic specialists determine what that transmission means. They analyze encrypted communications, coded telemetry, and complex digital exchanges designed to resist interpretation. Modern military and space systems are software defined. Commands are issued through data packets. Control flows through networks. Encryption protects those flows. The cryptologic analyst studies the architecture beneath the encryption. Their task is both technical and strategic. They examine patterns in communication. They identify anomalies in protocol. They assess whether a signal represents routine activity or concealed preparation. When adversaries test new capabilities, those tests often appear first in the logic of their communications. Information dominance rarely announces itself loudly. Cryptologic analysts work with advanced tools and mathematical frameworks. They must understand network structures, cyber vulnerabilities, and signal behavior. Precision is essential. Misinterpretation can distort the operational picture. This role bridges cyber and intelligence. It exists at the seam where data becomes strategy. In space operations, decisions are often made before visible effects occur. Understanding encrypted communication streams can provide that early insight. It allows leadership to anticipate rather than react. But understanding data and decrypting intent still leaves a practical question. If conflict emerges, which assets matter most? That responsibility moves from analysis to prioritization. Targeting. Targeting analysts convert intelligence into consequence. Space systems are few, expensive, and strategically vital. A single satellite can enable secure communications across a theater or provide missile warning to an entire nation. In any contested scenario, decisions about priority determine outcomes. The targeting analyst studies adversary capabilities and identifies which systems matter most. They assess vulnerabilities in satellite constellations, ground stations, relay nodes, and supporting infrastructure. They examine redundancy, resilience, and points of failure. Every system has dependencies. Their work is analytical but forward-looking. It asks what would happen if a specific asset were degraded. How would an adversary compensate? What secondary effects would ripple through communications, navigation, or intelligence networks? Precision is critical. Overestimating a target wastes resources. Underestimating it invites surprise. Targeting also informs defense. By understanding which of our own assets would be prioritized by an adversary, Planners can reinforce, distribute, or redesign critical nodes. This discipline is not cinematic. It is systematic evaluation of importance under constraint. In the space domain, where infrastructure is sparse and interconnected, prioritization shapes deterrence. Clear understanding of what matters most reduces miscalculation. Yet prioritization depends on accurate visualization of physical infrastructure. Satellites orbit above Earth, but their support systems reside on the ground. To see that physical layer clearly requires geospatial intelligence. Geospatial intelligence analysts turn imagery into insight. Every launch complex, tracking station, radar array, and support facility exists somewhere on Earth. Satellites orbit overhead, but their lifelines run through concrete, fiber, and terrain. Understanding that physical layer is essential to understanding space power. These guardians analyze satellite imagery, infrared detections, and other sensor data to identify patterns on the ground. They monitor construction at foreign launch sites. They assess changes in infrastructure. They track activity around facilities linked to missile programs or counterspace systems. Pixels become evidence. A new building appears near a tracking array. A runway is extended near a launch complex. Vehicles cluster where they did not before. Each change is small in isolation. In context, it signals preparation. Geospatial analysts provide that context. Their work supports targeting decisions, strategic assessments, and operational planning. They help determine whether an adversary is expanding capacity, dispersing assets, or preparing for a test. Accuracy matters. Imagery can mislead without careful interpretation. Shadows, seasonal changes, and construction phases all complicate analysis. Discipline separates signal from assumption. Space competition does not occur in a vacuum. It is anchored in physical infrastructure. Geospatial intelligence grounds the orbital picture in reality. But even the clearest understanding of infrastructure and intent collapses if the networks that carry the data are compromised. That is where cyber operations becomes decisive. Cyber operations specialists defend the nervous system of the Space Force. Satellites are controlled by software. Ground stations are connected by networks. Missile warning systems rely on data integrity measured in milliseconds. Every orbital maneuver, every intelligence feed, every targeting assessment flows through digital infrastructure. If that infrastructure is compromised, space power collapses quietly. Cyber Guardians install, configure, monitor, and defend mission systems. They secure satellite control networks. They harden communication links. They detect intrusion attempts and respond before adversaries gain persistence. Modern conflict often begins in code. A malicious actor does not need to destroy a satellite physically if they can disrupt its command pathway. They do not need to jam a signal openly if they can corrupt routing tables or manipulate authentication systems. Cyber operations specialists anticipate those moves. They conduct defensive operations, vulnerability assessments, and incident response. They enforce standards. They ensure systems comply with security frameworks. They isolate anomalies before they become breaches. Their work is constant and procedural. Most days pass without drama. That is success. Space superiority without cybersecurity is an illusion. This role closes the architecture. Operators manage satellites. Analysts interpret threats. Targeters prioritize risk. Geospatial specialists anchor assessments in terrain. Cyber ensures the entire structure remains intact. 7 enlisted roles, 1 integrated system, and the system runs every hour of every day. The enlisted force of the Space Force is compact by design. There are no infantry battalions in orbit, no armored columns maneuvering through vacuum. What exists instead is infrastructure, satellites, sensors, networks, data flows measured in milliseconds. Each of the 7 enlisted roles exists to protect and operate that infrastructure. Space systems operators keep satellites functioning. Intelligence analysts interpret the competitive environment. Signals and cryptologic specialists extract meaning from electronic noise. Targeting analysts prioritize what matters most. Geospatial experts ground the orbital picture in physical reality. Cyber operators defend the digital backbone that holds everything together. It is a layered system. Remove one layer and the structure weakens. Compromise cyber and satellites lose integrity. Misread intelligence and deterrence falters. Misjudge targeting and strategic balance shifts. The Space Force Enlisted Corps is technical, analytical, and small compared to legacy services. That is not a weakness. It reflects the character of the domain. Modern civilization depends on invisible infrastructure in orbit. Banking transactions, navigation systems, missile warning alerts, secure communications. All of it runs through systems these guardians maintain. Space is no longer distant. It is operational. If this breakdown clarified what enlisted guardians in the Space Force actually do, consider supporting the channel. Like the video so more people understand how space infrastructure quietly shapes daily life. Comment below with which specialty you would choose and why. And subscribe if you want deeper analysis on space power, emerging technology, and the strategic architecture of the new space age. We are entering an era where orbit is no longer symbolic. It is strategic terrain. Understanding who operates it is the first step toward participating in it. This has been Gene Botkin with Elenarda. End transmission.